Hello there. I hope you are doing well. So, on the last stream, I talked about implementing this Voxel Raymarching um, algorithm to speed it up, and I spent an hour last night implementing it, and it does work, and it does speed it up quite a lot. However, if I run it on the stream right now, it's probably going to be laggy. So I'll just give it a little test run, and so you can see the results even though the frame rate will be low. I won't talk because I don't know if my audio will come through. So here's a little look. So if you looked at the video, then you would see that there was sort of blobby voxels all kind of stuck together. And as I moved out of the chunk, they're just completely removed. That's because in the program, where is it? Somewhere here. Sampling the SDF numbers here. And if the SDF number is greater than 0, then we move along the ray. But if the SDF number is 0, which is what it will be if you're standing outside the chunk, then it just runs this function, which is not going to work. So that's kind of why it's invisible if you're outside of a chunk, which basically means the sign distance field value, well, it means that you should always have all of the chunks around the player loaded, which is kind of what you want anyway, so it's not really a big deal. But the performance problems, well, the performance is a problem, is what I should say, and the reason it's a problem is because I want to develop most of this on stream. And if I can't look at the game on stream without it lagging, well, that's an issue. So one potential solution to that, which I was doing previously, was we don't actually render the whole chunk at once. So there was just a small amount of visible voxels. But the problem with that is, well, I kind of do want to see the whole thing. Actually, this might work. I'll do that little viewport thing. So we had the viewport that was taking up 1/3 of the screen. Let's see if we can run that, and I'll have a look at the stream quality on the right hand side over here. So as you can see, we can look around. Yeah, it looks like this is okay. So having a little viewport into the voxel world seems to be working. It's kind of hard to show you the artifacting now, but you can see as I'm walking closer and further away, I'm getting these sort of spherical shadows. And I was going to investigate what that's from. So a friend of mine who's done a lot of Raymarching and ray tracing stuff says it's probably from not using a particular algorithm called DDA, which is, if I look it up, I don't know how to explain it because I only vaguely understand it, but it's a line drawing algorithm. Now look, geeks for geeks. It's a line drawing algorithm that's used to generate a line segment between two specified endpoints. Okay, well, let's look up DDA Raymarching. Okay, we'll have a look at this Reddit post. It's easy to find with a Google search. Well, thank you. Used for rasterization of lines, triangles, and polygons. I don't think this is really... I mean, maybe this answers it in an abstract way, but I think what we're actually interested in is DDA, I think, gives you an optimal line length to move down as you do the Raymarching. I think that's what it's used for in Raymarching. But we're not really doing that. We're just saying, well, we've got our SDF. So we move and we do a sphere trace, right? So we do a sphere trace, and we get the next closest value, but then we use map local, which is just using smin, looking up in the texture, and so I don't know if this is really a problem. Let's see what happens. I think it might be actually a problem with calculating the lighting and all that. So if I actually go down here, and we just say the color is going to be none of these things. I'm not going to have a sky. We're not going to have lighting or AO. We're just going to say the color is the material color. Of course, it's going to be flat. So I'll have to look at edges to see. Yeah. Interesting. So if I move back and forward, yeah, as I suspected. So I think that this error is actually from, and my friend couldn't have known this to his credit, it's actually from the fact that when we calculate the normals and the lighting, we're using this local map, and map local actually only iterates over a much smaller subset of the level. So it only considers a 5 by 5 area around. So if I change this to a 1, it's going to be a 3 by 3 by 3, as we kind of talked about. And then if we go down to, where is it? Down here. And if we say, actually, let's just run this first, if this works. Yes, this looks generally correct. There's a few, it looks like there's a few gaps, because that's not lighting. That looks like a gap in the mesh or something, right? Like it's broken somehow, which maybe is possible. Maybe we're looking at the back of the mesh. That's fine, we can sort that out. But the next thing I want to look at here is, well, how are we doing the lighting? The lighting is done with this calculate lighting function, which admittedly doesn't use that local map. So we can probably use the lighting here. So we'll say material color times lighting. Okay, now we've got some more. We've got some lighting in the scene. Apparently, doesn't look like it. It's quite dark. The lighting is what's the direction? The light direction is coming from the top. So we probably want it to come from the bottom. Just because of where we are right now. So yeah, it's coming from the bottom now. There we go. Okay, we can sort of see the clumped voxels here. So if I walk out of the chunk, we don't see them. I only see them inside the chunk. That's fine. Okay. I mean, the shape is not what I want as the final shape. It's just sort of experimentation. But yeah, we can kind of see that's working. I'm going to actually make it come straight up from the bottom. I think that'll give us a better result right now. It's a bit, I don't know, we are getting those artifacts now. Can you see it? Okay. So these artifacts are happening in calculate lighting. Why is that? Because we're using calculate normal, and calculate normal uses a local map. So we're calculating the normal based on only a 3 by 3 by 3 area, which could be a problem. But if we want to, I'm not sure if we can make this better. Let's say we make a map function, which is just the convention. I don't know why it is that convention. And we just say p, and then actually I'll just copy this essentially. Actually, no, I don't need to copy that. I will anyway. I don't think we care about the center because we're not doing the same. We're not going to do the same bounds checking. Basically, we're going to check everything now. So I'm going to get rid of center. And the min bounds is just going to be 0, and the max bounds is going to be chunk size. So I guess I'll just change that here. Okay, and then that's all good. We still want to use the smin. I think that's fine. Now if we use this map, it might be really laggy. Let's see. Unexpected. Right, oh yeah. Okay. It is laggy. It's too much. It's too much stuff. Okay, so calculating the normals this way, we're basically doing 4 maps per pixel just to calculate the normals of 1 pixel, which is maybe not the best. My same friend did actually tell me about an interesting article. Here it is. It's called Raymarching the Gunk, and it's about a game called The Gunk. Okay, and here it is. So this is by Jarl Larsen. That's an interesting first name. And I can't zoom in because my scroll wheel, there we go. All right, there we go. So there lists a game called The Gunk, and as you can see in this video here, it's got all of this really cool sign distance field gunk that's getting sucked into the gun here. And I think this is mixed with, I think that's rasterized ground. I'm not 100% sure, but I think so. I haven't read this article yet. But you can see here, this is actually an Unreal by the UI. It looks like it's in UE. It is. So they've got sphere-shaped actors based... okay, they've got sphere-shaped gunk actors in here. Interesting. Before the game level starts, a set of sphere-shaped actors are loaded that define where the gunk should be. These are placed in the levels by the level design team. They use regular blah blah blah. Okay. So gunk sphere actors are voxelized into fields of voxels. They're used for the game to look up how much gunk is left and where, and also to handle the collision against gunk. The voxels serve as a basis for the sign distance field, which is what we use to Raymarch the surface. Just Raymarching the field gives us the rough shape in the image above. Right, this one here. Okay, that's cool. Raymarching gunk with added detail using noise textures. Okay. Coloring is done through regular Unreal material. That's really cool. So they add the gunk using this tool here, and they can visualize it in real time in the editor. Huh. That's really cool. So, here's a look at their voxels. So they've got sort of a visualization system here. The voxels are, looks like that must be the value, the large and red square, or the small blue square in the center is sort of, I guess, maybe volume. So how much gunk is in that particular voxel, perhaps. which is pretty interesting. Voxel HP is shown in the square. Bigger equals more HP. Yeah, kind of the same thing. So voxels in the gunk are generated using single precision floats, which generate the health points for the voxel. That's interesting. Gunk must not be spawned inside the level geometry like floors and walls. However, as we use a sphere-shaped actor to define, we can consider that they might overlap. So they just remove gunk inside geometry by visualizing it, geometry inside the gunk areas, and then subtracting the gunk voxels. Alright, that's cool. Players can absorb gunk. I wonder how this game did. This is really interesting tech. It got 1,600 reviews and 4.5 stars on Steam. That's really good. Sounds like it did very, very well. IGN gave it a 7 out of 10, but that's what it gives every game. And who cares about IGN anyway? Let's have a look at VG Insights to see a few stats. This is pretty rough. Sometimes it's wildly off, VG Insights, but it can give you sort of a ballpark idea. Generally, the more popular the game, the more... What the hell just happened? The more popular the game, the more accurate it is. Okay. You ain't working for me. I want to go to this game, please. Right. Made apparently just under $1 million, which is not much for the amount of reviews that it has. That's interesting. I don't know how big the team was. But yeah, that's not a lot of return on investment, which is a shame. This stuff looks pretty interesting. I don't know what the game is though. If it's just clearing gunk, that doesn't really sound interesting to me. As much as the tech is interesting. And this article is very, very nice for them to have written up. What's JFA? So generating the SDFs and the clip map. Voxels to distance field using jump flood algorithm. Voxels are sent over to the GPU as a buffer of floats along with dimensions, but to render the voxels as a smooth surface, we need to first create the distance field from them. Our SDF generation pass creates a new volume in which each cell has a value that is the distance to that cell's closest surface. Yeah. Okay. Okay, so the jump flood algorithm is a way to speed up this generation. It's implemented in a multi-pass compute shader. That sounds good. I've got this kind of algorithm, but it's just the brute force dumb version. I'm just doing it on the CPU right now. JFA will run until a step size is 1. Okay. So this is stored in a texture, I guess. Distances from each cell to its stored coordinates are calculated. If the cell is also overlapping with a filled voxel, then we know the distance is inside, so we flip it, i.e. flipping the sign. It's a simple way of differentiating inside and outside distances. Yeah, okay. Right. So, okay, interesting. So, they've got this big green volume here. Is this big green volume the whole SDF for the player? There's a little heat map kind of thing up here, which is anti-aliasing on the JFA seed values, allowing us to scale individual voxels as well as smoothing edges. Right. So I guess we could start rematching the volumes. If the amount of SDFs and the draw distances vary a lot, the performance might fluctuate too much. In order to even it out, we draw the SDFs onto a volumetric clip map. The clip map has 3 levels of detail, so SDFs farther away are drawn onto a canvas with lower resolution, while the ones closer to the camera are drawn at their natural resolution. SDFs are drawn onto the clip map only when the clip map moves. The clip map moves in large discrete steps to lessen the amount of times it needs to update and to not get aliasing/flickering. The clip map's position is aligned with the camera. Okay, I don't know what a clip map is. But that sounds like a pretty good optimization. So they've got a custom noise renderer, which can render and bake volume texture. Okay. Raymarching gunk to render targets. So this is probably what I want to look at here. So let's see. Raymarching is a way to render volumes. It works by stepping into the volume until a step has passed a threshold value. This is done for each pixel to be rendered. It's commonly used in games nowadays to render clouds and wisps of fogs. For transparent rendering like clouds, it'll accumulate density values along its step. In the gunk, we treat the gunk as opaque, so when we hit the surface, we output the pixel depth immediately. There's a little diagram down here of a camera looking at some gunk from the side. I think it might be maybe top-down perspective. And then as soon as the Raymarch hits the edge, it considers that to be a hit. That makes sense. The way we step is determined in Raymarching can differ. As we have distance values per voxel from our SDFs, we use them to determine the step size. This helps us keep the number of steps down, which is important for getting them running fast. The amount of steps per pixel is the biggest performance bottleneck for these kinds of algorithms, as they can cause the shader to become too sequential and hinders parallelism due to threads having to wait for each other. Yeah, so this is basically the problem that I'm having, I guess. Too many steps per pixel. But also, I'm sampling the whole scene for every pixel, which doesn't really make sense. So I want to see what the solution is for that. So, this variant of Raymarching is also called sphere tracing, which is the same one that I'm using. For the gunk, we define the threshold for a surface to be the size of a pixel's spherical bounds at that distance from the camera, given the view projection. This can be referred to as cone tracing. We use this even more extensively in a pre-pass, which I'll get into soon. Okay. Maybe I need to look into what this means. Do I have a highlighter? I do. It's going to highlight that. Yes, thank you. Tracing from the camera to the gunk. Yep. Distance compared to the screen's pixel coverage to determine if it was hit. Okay. Simplified, the core Raymarcher looks something like the code below. On the CPU, we calculate a scale factor of a pixel's size along the depth of the camera frustum, so we can use it to determine when a pixel intersects a surface. Ratio of diagonal to a side of a square. The Dotwolf says maybe you should take a look at Sebastian Alton in the presentation on Claybook. Oh, I've seen him on Twitter a lot. That guy. He did a lot of work with Raymarching SDF. Looks similar to what you're trying to do. Okay, thanks. I will have a look at his stuff. Sebastian Altonen. I've seen Claybook actually. Okay, he's got a video here. Looks like this is the GDC presentation slides. Yeah, this guy. I've seen him on Twitter a lot. Okay, cool. I will definitely check that out. Thank you. Set the pixel size in the world on the camera origin viewport is 2 units wide. Okay. How much the radius of a circle encompassing a pixel is, depending on how far away the camera it is. Yeah, I don't have this pixel cone radius by distance. So that could be something. I don't have a depth pass at all. So they send that into the shader, and the clip map levels are iterated and each are marched through until something's hit. Okay, so I need to look into clip maps as well. I'm going to go back up here. I'm just going to put a little highlight here. Okay, so just looking at some code here. This is just some Raymarching. It's interesting. This seems to be C++. Each clip map level, its volume texture is marched using a function similar to the simplified one below. Or is this... Oh no, this might be DirectX. Float 3. This is... Yeah, I don't know what language this is. Maybe this is just pseudocode. The function called a sample gunk samples the texture at the given point. It also applies details that we want on a per ray step resolution, like detail, noise, texture sampling, particles, etc. Okay. So as our final SDF that we step through is layered in the form of a clip map. We start by stepping through the nearest clip map and continue through the following until a surface is hit. A line to AABB test is used to find the start point on the clip map's surface level. Oh, you think it's HLSL? Yeah, okay. The clip map level have roughly the same texture resolution, but different world size. That way we're effectively sampling max 3 base shape SDFs per pixel, and we get a lower level of detail the farther away. Yeah, I was going to look into something like this. Is a clip map like a MIP map? I don't know. The same clip map as seen from the player's point of view. Okay. What? So is the player down there somewhere? Not sure. The full rendering without the debug visualization. They're using geometry clip map. Yeah, I don't know what that means though. That's why I highlighted it. A terrain technique. Okay. Alright, so each clip map level's volume texture. We're gonna add animated displacement noise. Okay. This part I can look at later. Another transient effect is the camera hole. Okay, yeah, I don't need to know about that right now. One simple way of shaving away lots of empty spaces to do bounding volume tests first. Yeah, I was planning on doing something like this actually. Where I just shoot a ray into the world and then see which chunks it hits first, and then only concern myself with those ones. But I can't even get one chunk rendering at a decent frame rate. Well, actually the frame rate is fine for my computer, but for OBS it's not fine, which probably tells me it's not fine. Yeah, so we want to minimize the amount of steps needed per pixel. So in order to do that, we want to skip as much empty space as possible. Finding the closest bounding surface. Well, in our case, in this case, we are already inside a chunk. So that's not really necessary right now. I did have a sort of idea though, which is I'm going to try using a sphere instead of a box. I just want to see what it looks like. So it'll be SD sphere, which takes a point and a radius. I'll just do 0.5. I'll just do the same thing here. Oh, apparently I can't do that. What's the problem with this? Oh, I forgot the blending amount. Okay. Well, that definitely looks quite blobby. Oh, I'm having some overloading and coding. Wow. Seb's technique is to have a bunch of mipmaps of the world texture. This way you can sample the lower resolution to skip a lot of empty space. Yeah. I understand. I think I understand that. I've already kind of covered that though. So skipping empty space is not the problem right now. I don't think. Because if we look at this, is it this buffer here? Not this one. Is it this one? No. Oh, I need to actually run the program for us. 1 second. Let me have a look. So this buffer here. So anything that's -1 is inside, inside the chunk, but I mean inside the geometry. But there's a bunch of numbers here like 5, 6, etc. These are actually 7. These are distances to the nearest surface. Roughly, they're minimum distances. So they're basically like distance to an edge around the surface. So these voxels are always going to be 0. And that's when I start the next type of Raymarching. So I always skip. When I'm standing inside the chunk, I always skip until I'm right next to the geometry, and then I do the sphere trace. But even that is too slow. Am I uploading the texture each frame? I don't think so. I don't know why the lag is, actually. Lost a few streams. Yeah, that's fair. So each frame, I don't think I'm doing any uploading. Let me have a look. Map memory. So I'm uploading some debug shapes and camera position, and some coordinates. What is this for? No, this isn't doing anything. Actually, I'm not doing anything with this data at all. Coordinate, I'm not even setting this, so this is just getting mapped and unmapped, so I should probably just comment this out. SDF pipeline, I'm uploading the camera position, forward, up, the window size. That's it, I think. Copy data to image is happening once. So this is where I copy into the 3D texture here, which is before the main loop, and also the scalar field values as well. I was going to combine them so that I would have the scalar field values in the 3D texture, but I just haven't got around to that yet. So yeah, I think it's just, well, I learned how to do ray tracing, not ray tracing, sphere tracing, or sphere marching. Sphere tracing? No, it's sphere tracing with Raymarching from like a shader toy examples and tutorials that use shader toy. So I have a feeling that there's some big gains to be gotten from something. Like maybe doing it in a compute shader somehow. I mean, not somehow. I'd probably have to use a frame buffer texture and then something. Because I'm doing it in the fragment shader, but I don't know if doing it in the compute shader would just be better. Gonna have to spend some time on NSI or Pixlate. I don't know what that means. What is that? Oh, NSight? Right, yeah, I was actually gonna look at this, because RenderDoc doesn't give me timings, does it? Unless you know about that. Yeah, Yeah, I was actually gonna try this. Can I just download it? Yeah. Okay, we'll see. I don't know if it's just gonna work. I saw Ace Roller using this in one of his videos, and it got me intrigued because it seems like it has more information than RenderDoc. It has a simple timer. Okay. Just on call. Alright, I'll have to figure out how to use it at some point. But for now, see, I'm not sure, to be honest. Not sure what to do. I mean, without any understanding of what is wrong, or rather what is slow, I can't do any optimization. I'll just be guessing. So maybe I will just look at this when it finishes downloading. Man, is it huge? No, it's just really slow. Why is it taking so long? It's only 300 megabytes. Probably the Nvidia didn't pay for better servers. With all their money, all the AI money, and they still can't afford servers. Also, I didn't check if S-min is having a big impact on performance. It might be. Uh-oh. Nope. Still overloaded. Crazy. Yeah, it's got to be from the normal calculation, right? Because I'm sampling the whole map. Is there a better way to do this, maybe? Neat, but you can see the shapes. Yeah. That's why I like the smooth min. But this is a big problem. Calculate normal. So, yeah, I know, without profiling, I can't really tell either. Yeah, okay. Let's have a look. It just finished downloading. Will this just work? It would be a miracle. Yeah, I've got a 3090. What? Do I want to enable usage collection? Sure, why not? Okay, so, okay. Whoa. Wait, what am I allowing access? Oh, something. Okay, new project, open. Oh, so I want Insight graphics, not Insight systems. Well, apparently that's not a thing on Windows. Maybe I downloaded Insight systems. Right, I probably downloaded the wrong thing. Yeah. Silly me. No, I just downloaded systems. I didn't realize there was something called Nsight systems. I just searched for Nsight and it was the first one that came up. I want to support render doc. I don't want to be NVIDIA shill. Has some really cool features too, like snapshots. Who's he? I did find this performance counter thing, but I just didn't seem to do anything. Well, I just don't know how to use it. RenderDoc has a small clock on the controls. You can take a simple timing. Alright. Could not find Nsight. Oh, so I need to have Nsight installed to use the NVIDIA timing thing. Okay. This is more for counting vertices, pixels, etc. Oh yeah, I see. Yeah, invocations, input primitives. Okay. On the event browser SDK. Well, I'm just going to try Nsight first. Wait. Do I just want to open this? I used to do a lot of switch ports. That's cool. Switch supports Vulkan, right? And then also the Nintendo SDK. Switch supports RenderDoc. Oh, that's cool. Okay, so new project, test, application executable is going to be here, and this is going to be this directory. Don't need command line arguments. Automatically connect. Yeah, I guess so. Frame debugger. Generate C++ capture. GPU trace profiler. Profiler and applications use of GPU resources. Okay. Trace in frames mode. Alright. Sure. I guess I'll try this first. I don't know. Press F11. Okay. Data collection not available. No, Shift F11. No, that's just cycling a position. What the hell? Now, connection error detected. Communicating with target application. Shutting down connection. Target platform is not supported. GPU trace couldn't initialize. Right. Oh, wait. Can you give me more information, please? No? Failed to initialize periodic sampling. You might not have permissions to access NVIDIA GPU performance counters on the target device. What? You mean I don't have access to my own hardware on my own device? Okay. Nice. Run with elevated privileges. Okay. I'll try that first. Save the project. Yes, sure. Okay, we'll start a GPU trace profile. We'll try that again. Why do I have to... Wait, what happened to my project? Oh, it's going to be because I'm a different user. I got to make a new one. Fine. Oh, Twitch ads. Gross. I didn't even know that they run ads. What happened? Basically, it said I don't have permission to access the profiler on my computer. So I need to probably... Damn it. Run it in administrative mode and then see if that works. And if that doesn't work, I've got to do something else, I guess. Okay. Yeah, alright, it's good. It's working. Okay. Yeah, I know. I terminated the connection. Yes. Okay. Transferring the data, apparently. Let's make this bigger. Oh, this is very complicated. Alright. Okay, missing debug info. Well, that's not great. So we can see the biggest offender by far is this, which is exactly what I expected. So this is the Raymarching draw command. Draws 6 vertices, which is just a quad on the screen. And it takes 18 milliseconds per frame. Can I see any other information about this though? So texture fetching is taking 51% of the time. Oh, interesting. Wait, no, it's got the most samples, but it's only taking 3.8% of the time. Is that what that means? I mean, it's the number of instructions, which is not exactly the time. So let's see. Is there something over here, maybe? Okay. Texture fetch, 83.62%. 40% of the instructions. Special function. Or whatever that is. Okay. So there's some floating point math. Okay, this is the assembly, which I don't know how to read, but this is the SD sphere. Gonna have to study a bit. Yeah, it looks like it. Alright, send me a link, thank you. The peak performance analysis method for optimizing any GPU workload. Well, that's useful, yeah. Damn it. I can't zoom in because my mouse is broken. There we go. Actually, I can press Control Plus, can't I? Yeah. What am I doing using my mouse like a scrub? Alright, cool. I'll have a look at this a bit later. But yeah, from what I can tell at the moment, it looks like texture fetching is definitely taking up the most amount of time, which makes sense. So image sample implicit LOD. I don't know if we can make that faster because we need to sample the texture to know what's in there. caching the texture data locally in the shader even do anything? I don't even know. I've never optimized shaders or anything like that. Yeah, most of the optimizations that I've ever done to do with graphics is just reducing the amount of triangles that I'm sending or the amount of texture switching or something like that. This is new territory for sure. So if you ever scroll down here, most of the stuff is inconsequential. I think it's really just these three things. So this is SD sphere. This one is also SD sphere. And this one is, where is this? Subtracting, converting something to a float, loading from the texture. Oh, okay, it looks like this is part of the getting the texture value. Can I go up here? What's the function called? Wow. There's a lot of stuff going on here. Map local. Okay. I don't think you can help via Twitch chat. That's fine. I appreciate the effort though. Yeah. So it's definitely something that I need to check out. So texture fetching is slow, huh? I thought 3D texture fetching was fast. That's the whole point. I put it into a 3D texture. Otherwise, I just use a buffer. Or maybe that would be even slower. Can reach you on Discord later if I have issues. Thank you. I appreciate that. Yeah, I'm sure it's just a matter of reading a little bit more, and understanding a bit more about Raymarching as well, which would be quite helpful. But if we have a look here, we've got capturing the frame, breaking down the GPU frame time, profiling a workload. So why don't we have a look at step 2? Actually, we didn't do a frame. We did a different kind of profile. So let's see if we can try a frame debugger, which is a bit different. I just want to see what that looks like. Hit F11 for frame capture. Okay, there we go. Oh, okay, thank you. Now what? Whoop. All right. The stream is going crazy. Okay, profiling is not supported on Vulkan devices with the validation layers enabled. Oh. Well, that's not cool. Alright. That was a failure, sadly. Okay, well, let's have a look at what these guys say anyway. So, range profile effectively calls set stable power state. Okay. Inspecting top SOLs and cache hit rates. Huh. So there's a range profiler. Yeah, of course. GPU cache hit rates might be a big problem when sampling from a 3D texture. I don't know if this has that information. Hotspots. This is the biggest hotspot, which is texture sampling. Okay. Don't know. I don't really see anything else here. I mean, there's a lot of stuff. What's this? Viewport, cursor, trace. Yeah, so I'd have to turn off. I guess it's not hard to turn off the debug pipeline. Where is it? I'm in the debug layer. Look at the appendix. Appendix. In here? Is it in inside, or do I have to go to the website? Let's have a look. Trace information, metrics. This one. It's a lot to read. Oh, in the tutorial. Oh, in here. Blog post. Yeah, let me have a look. The appendix. Okay, there's two. Optimizing Raymarching loops. Oh. Nice. So, loops containing text instructions. That's a texture lookup, right? Can be limited by latency of text instruction and the fact there are no independent instructions that can be scheduled from the same warp. Sorry, there's a delay. That's okay. No problem. So there's no instruction level parallelism. Okay. That number of active warps in the SM is insufficient to fully hide text latency. Okay, Raymarch volumetric lighting. Oh, another thing I was considering, by the way, is actually having mostly rasterized geometry and then using Raymarching for particular effects, like blobby, goopy stuff happening in the horror game. I think that could be interesting. That could be a potential trade-off if I can't optimize this to run in real time on a 1060, which is pretty possible. I mean, pretty possible I won't be able to do that. We'll see. Okay, so these guys say, so this is a Raymarch loop. At sample depth. Okay, yep. If the ray hits, then blah. Otherwise, unroll the loop. Yeah. Okay. By implementing the above optimization on a 1080, got a 29% speed up just by doing 2 texture fetches in this. What? And when they did 4 instead of 2, it went down to 0.33, which is a 64% speed up from the original. That's crazy. So unrolling the loop, huh? A lot of games do clouds with Raymarching, like Red Dead Redemption 2. Yeah, I've heard that, and I think you can get some cool smoke and fog and stuff with it as well. I really like the merging effects, you know? If I look at IQs, I can't just search for IQ. IQ STF, there we go. IQ's website. If I can find that article again, where was it? Raymarching. I think it was something about BVHs, but it was in this section here. Let's see. Bounding volumes maybe? Or binary search? Or... yeah, this. It's just so interesting to have this kind of deformation. Yeah, Inigo. I just call him IQ. Maybe that's... I mean, that's his initials, right? Yeah, very interesting stuff. I think it would be great for a horror game. But just getting it to run in real time. He even says in that article that I think that video is sped up by 10 times or something. So it was just a one night project. He thinks he can make it faster. Where is it? The performance is still pretty bad. Single digit frame rate on his laptop computer with a GeForce 1070. But you can see nice soft shadows and etc. So yeah, this is actually a sped up video. It's not running in real time. Can't help a lot. You've only done the basics of Raymarching. Yeah, that's fine. Me too. I mean, I've only just done the basics of the basics, so we'll see how it goes. But I mean, yeah, then I saw what you was talking about before, Clay World by Sebastian. Yeah, that's not what I was looking for. Clay World game. It's this one, right? No, that's not it. Is it called Clay World? Am I crazy? Let me go up a bit. I think you talked about it up here. Claybook, right? Sorry, my bad. This looks more like it. So yeah, I saw some of this. And this is all running in real time on, I think on a PlayStation, right? As well, PS4. And there's also Dreams as well. Dreams uses similar techniques. It's all pretty interesting. Yeah, Claybook, that's right. Pretty cool. Yeah. I wonder how they do lighting. Because that's really a big problem here. Calculating lighting. Well, it's actually the normals in this case. So if I don't calculate the normals, and I just say the normal is going to be oh yeah, he uses SDF Raymarching inside Unreal 4. Interesting. So if I don't calculate the normals, then I think I just built that. Performance will be much better. Yeah. See, I'm not dropping frames now in OBS. It looks totally fine. But of course, you know, there's no normals, which means the lighting doesn't work. So I can tell that that's a big bottleneck. I can speed it up somewhat by only sampling nearby geometry by using map local here. But then that gives me a different problem. I think that should help. Yeah, so we do get lighting, but actually it looks fine. I mean, it looks a little bit weird. So you can see it's kind of flickering and stuff. Maybe it's not coming through on the video. But yeah, it's not quite right. However, if we change the color of the material, I'm just thinking like, okay, I'm making a horror game and this stuff's going to be mostly used for horror things. So what if it was like dark, almost really dark purple color? Could I get away with that normal calculation? Looks like it, maybe. I don't like this though. What is that? That's very odd. Some bands between the samples, yeah. Also, it looks like there's some issues with the geometry here, I think. I can't tell if it's an issue with the geometry or if it's like a weird reflection. But I think it's an issue with the geometry. So if I change the light, see what we are using the lighting, so that's fine. but if I just set the lighting to like ambient lighting, maybe 0.2, whoops, and build that, and we'll have a look at what that looks like. It's going to be quite dark. Yeah, you can still see those gaps there. So it's some kind of issue with the mesh. No, it's not a mesh, actually. Oh, is it inside? I think it's inside the cubes, because these are spheres now, and the spheres are smaller than the cubes. Looks nice. Yeah, I think it looks pretty cool. Very 90s. Yeah, actually, I'm going for a bit of a lo-fi look in general. So I was actually even thinking about cutting the resolution in half, which would, of course, really help with Raymarching, but also give me a bit of more of a pixelated look, which I'm interested in. I mean, yeah, this is not final, but you know, it looks okay. I'm gonna have to profile it, but I need to learn how to profile properly. Also, I could try unwrapping, not unwrapping, unrolling the loop. So this loop is the ray. Okay, so this is equivalent to this loop that I got here. So it's this loop. So where I'm sampling the SDF numbers here. Although the interesting thing is, that's not a texture lookup. So the text lookup is actually here in map local. So maybe it should be this one that I unroll. Yeah. I think you can actually do that with a pragma. So I need to specify what I'm talking about. Vulkan, GLSL, pragma unroll loop. Oh, it's NVIDIA only? Right. Well, that's unfortunate. I mean, is it? I mean, why is this hard to look for? I know there's a pragma for it. Why is it not like, here's the Vulkan documentation, here's the command. It's probably pragma, so it's going to be the compiler, whatever the compiler is for the shader, which is, what am I using? GLSLC. Okay, I'll just look for that. GLSLC. No, I said GLSLC. Why would... it's fine. Nice. Stop changing my search results. Is it a fixed size loop? If it is, you should unroll it. Is it a fixed size loop? If it is, it should unroll for you. No, it's actually based on... Well, it is fixed size, actually. This is a 3 by 3 by 3 loop here. But I'm not sure if the compiler can tell that because it's using the variable here. So it may not understand that. So technically fixed, but you can see the result after the Vulkan shader compile. Yeah, it's in here, right? So probably this one. Yeah, I think it was this one. Yeah, it was this one. Yeah, but I actually want to look at the SPV disassembly or render doc. I don't know how to see it in here. Is it the shader module? Oh yeah, right. Cool. Right, that's nice. This is the wrong shader though, I think. Don't know which one it is. Vertex index. So this is... What the hell is this? I'm unsure. That's okay. Well, we got another one here. Let's have a look at this one. Okay. Sampled image. Out color equals this. So this is a vertex shader, right? Pipeline. Oh, you think I should go to the pipeline for this? And have a look? You can pick the submit, the use, and use the blah blah. Sorry, you can pick the submit and use the pipeline tab. Dispatch. Right. Okay. I'm using a fragment shader, that's right. I'm not using a compute shader. So this one. 186. Yeah, here we go. Nice. Okay, so we want to find... Does it rename the functions or do they stay the same? Jeez. Smin, stsphere, map local, here it is. Shader on the top. Oh, right. Yeah, it's delayed. I think that was 30 seconds ago. Okay, so here we got while true, while true, while true. It's interesting that they all get converted into while true. Sampled image. It looks like it just happens. It's not unrolled. Unless I'm mistaken, that is not unrolled. So, image sample implicit LOD. Is that the function I should be using? I saw something like that. Instead of using the texture function. No. Apparently that's not a thing. Yeah, there's 3 whiles because we're using the 3 axes. So what if I actually just unroll all of these and it's a, well, maybe not unroll all of them, but I could unroll one of the axes and see if that helps, but I have to get a timing. And so if I go to main and I go to print line, I think I have a line somewhere. Not that one. Yeah, here we go. Delta time. So I am printing delta time now, and we can see it's 120 FPS right now, and it's remaining 120 FPS when I look at this. So I need to make it slower to see if I can make it faster. I will remove the... Try testing with a fixed number on size. Oh, you think I should try to make it unloop itself? So basically, I would change this to 0 and then change this to 3. And then I would change this to 6. C is going to equal to ivec3 min bounds plus, yeah, min bounds plus xyz. I think that's right. Okay, we'll have a look if that changed anything. Okay, here, and then we go to pipeline state, shader module 198, view contents, and down to, I want to find, what's it called? Map local. Okay, here it is. And moment of truth. We have not unrolled the loop. I'm pretty sure, yeah. Okay, that's all right. I'll try doing it myself. So basically, I just want to do this 3 times here. Instead of, I'll just unroll the z-axis. Hang on, but I want to compare it first. So let me calculate the lighting again so we can get a nice lag. I think that's laggy, right? No. Oh, it's totally wrong. What did I break? Did I compile? Yeah, I compiled. I just compiled again. I'll have a look. It's currently broken, but that's fine. It should not matter for these purposes. Map local. Yeah, still not unrolled. Yeah. I don't think the compiler knows enough about about it. The delay is very brutal. That's okay. All good. Why is there a delay anyway? Is Twitch chat always delayed? Or is it just... Did I need to change a setting or something? I don't know enough about Twitch. So what happened here? Why did I get a weird result? So this is actually... I think that code is actually wrong. Yeah. But anyway, regardless, I'm going to remove this viewport thing, this fake viewport, so I can get the lag, and it will lag the stream. It's not lagging. No, you're supposed to lag. Why is it not lagging? I think we need to calculate the lighting. Feels 30 to 40 seconds. Yeah. Oh, I'm calculating the AO, but I never use it. Shame. Okay. Yeah, it's not lagging, huh? Supposed to lag, please. Oh, it's because I'm doing the normal calculation with the map local instead of map. So this was probably why it's so slow. Oh, there we go. Alright. So that was like 0.12, 0.13 milliseconds. Not milliseconds, seconds. 0.12, 0.13, something like that. So let's see if we can make that faster by unrolling the loop in the map function. So the map function is not the map local function, they're different. Let's see if we can do this real quick. So we've got this function here. And I guess, see, it samples 16 by 16 by 16. Looks great, like an opal slash gem. Yeah, thanks. I think it looks pretty cool. So I'm just gonna unroll, I don't know. I guess I can increase the Z axis by 2 each time and do 2 on the Z. We can try that first. So UVW 1 and 2, I suppose. And I know this is really rough, but that's alright. And this should be, yeah, I think that'll work. So if Z becomes max bounds.Z, then it will stop. C1 and C2. And UVW1 and 2. And then here we say text val 1 and 2. And this is going to be C2 and C1. Okay. Let me just check the render doc first. Actually, I'll run it here and we'll get the timing for us. So 0.12, 0.13. Crap. It's frozen. Couldn't see the timing. Where is it? Alright. You have to go. Alright, have a great day, man. Thanks for your help. I don't think you sent me on an optimization side journey. I need to do it anyway, so thank you very much. Take care. Seems like no difference, but this should be, I mean, why don't I just put this as 0 and then this is going to be 15. Actually, no, it's not. It's going to be 8. No. It is going to be 15. Less than 16. Yeah. Yeah, that should be fine. No, we're doing 2. I'm stupid. 2 loops, so Z should increase by 2. Oh yeah, Z is increasing by 2 each time. Yeah, that's fine. So that should halve the amount of loops that we have to do, but that's apparently not doing anything. So let's do 4. And we'll change this to, that will be the same. So 0 plus 4 is 4. So it'll do 4 loops now. Which means we have to do 4 of everything. And let's see, 1, 2, 3, and 4. I think that's all good. Now, whether this will produce any noticeable difference, don't know. Let's have a look. Okay. So when I turned to the side, maybe? I'm not sure. I'm not sure why you're saying C++ or check out Rust. I'm not using C++, and I have checked out Rust. So, yeah, well, let's have a look here. So we had the texture lookup was taking 83% the sample time here. Let's try do another one. But that was a different scenario, so I'm gonna redo this. Build the shaders again. We'll do GPU trace. All right. So F11. Okay, did we get it? I think we got it. All right, interesting. So now it's taking 96% of the time, but all right, hang on, that's a different call. Let me have a look at this one. Is it this one? No, this one. So it was 51% and 80 something percent. Now it's 40% and 97% on the input dependencies. So I don't know what this means exactly. The data dependencies of the current selection that cause a short or long scoreboard stall. Data dependencies are predecessor operations that need to complete before code in the selection can proceed. Each item contains one or more source code locations of the given type that induced a wait time. So almost all the wait time is still looking up textures, which I suppose makes sense. It's a memory lookup, right? But then when I look here, self-instruction mix, the table shows a breakdown of all instruction types within the current selection. Each item contains one or more source code locations where the instruction type can be found. Okay. So does that just tell me that there are 40% of the code is looking up textures of the instructions? I guess I'll have to read that article. Which I will do on the treadmill at the gym because I have to go. So I want to thank you guys for tuning in, and I will see you next time.